Hello again, welcome to another lesson in geometry. Today we are covering section 6-2, properties of parallelograms. All right, so we have some vocabulary first. So supplementary angles are two angles whose measure sum to 180 degrees. So if you add up the two angles, degree measures, they should make 180. Suppose angle X and angle Y are supplementary. If angle X is 75, then angle Y would have to be, well, 180 minus 75, which would make 105. Okay. Underline the correct word to complete each sentence. A linear pair. Okay, so a linear pair are two angles that are adjacent and together form a line. So this angle and this angle form a linear pair. In a linear pair, it makes a line, so that's 180 degrees. So these are supplementary. Okay, straight angle. So AFB and EFD at the right are supplementary also. AFB is 60 and EFD is 120, and 60 plus 120 makes 180. So they don't have to be adjacent to be supplementary. All right. So we have vocabulary builder next. We have consecutive. Consecutive items follow one after another in uninterrupted order. So consecutive angles of a polygon share a common side. So just think of the vertices in order. So the numbers -3, -2, -1, 0, 1, 2, 3 are consecutive integers. They just follow right after another, no gaps. Okay. So non-example, the letters A, B, C, F, P are not consecutive letters because A, B, C, the next consecutive letter should be D. Okay. Use the diagram at the right. Draw a line from each angle in column A to the consecutive angle in column B. So consecutive angles are going to be right next to each other. So angle A is consecutive with B or F, and only F is on here. Angle C is consecutive with B and D, and only D is on here. And then angle D is consecutive with angle E or C, and only E is on here. Okay. Write the next two consecutive months in each sequence. So January, February, March, April. The next consecutive one would be May. And then after May comes June. And then December, November, October, September. So we're going in reverse. So before September would come August, and then July. So July, August, September, October, November, December. So consecutive just means they go in order without skipping. And all right, let's flip it over and check page 2. All right, on page 2, we have 4 theorems. Our first theorem says if a quadrilateral is a parallelogram, then its opposite sides are congruent. So let's draw a quadrilateral or a parallelogram real fast. So remember, a parallelogram is created from 2 sets of parallel lines. So in this case, the red lines on the top and bottom are parallel to the green lines on the left and right. Okay? All right, so it says the opposite sides are congruent. So my green lines should be congruent to each other, and my red lines should be congruent to each other. Our second theorem says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So the bottom left angle should be supplementary with the bottom right. And the bottom left angle should also be supplementary with the top left one. Okay, and so forth. All right, so if a quadrilateral is a parallelogram, then its opposite angles are congruent. So that means I can put these marks in here. And let's see if that makes sense. So remember, the bottom left and the bottom right are supposed to be supplementary. So this angle with the 1 mark should be supplementary to the angle with the 2 mark. And then the bottom left and the top left should be supplementary. So the angle with the 1 mark and the 2 mark should be supplementary to each other too. And that means we know that the diagonal ones are going to be congruent to each other because they're supplementary with the same angle. Therefore, they have to be congruent. Okay. All right, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So this is something new we haven't seen before. So the diagonal goes from one corner across the polygon to the other, and the same with over here. And they're supposed to bisect each other. So this length should be equal to that one, and this length should be equal to that one. All right. Use a diagram at the right for exercises 10 through 12. Mark parallelogram ABCD to model theorem 6.3 and 6.5. So remember 6.3 said if a quadrilateral is a parallelogram, then its opposite sides are congruent. So I should be able to mark AB and CD the same. And if a quadrilateral is a 6.5, I'm sorry. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So I should be able to mark A and C the same, and B and D the same. Okay. All right, number 11, it wants to know what is the same length as AE? So AE and EC should be the same because remember the diagonals bisect each other. So this half of the diagonal should equal to that half of the diagonal. And also BE should be equal to ED. So this half of the diagonal should equal that half of the diagonal. All right, use consecutive angles to help us. So that's this one right here. Quadrilateral has a parallelogram, then its consecutive angles are supplementary. Okay, so let's see. Suppose you adjust the lamp so that the measure of angle S is 86. So currently there's a little parallelogram over here, QRSP, and S is 64. So we want to adjust it so that S becomes 86. What is the measure of angle R going to be? So S and R are consecutive angles in this parallelogram, so they should always be supplementary. All right, so underline the correct word or numbers to complete each sentence. So R and S are consecutive angles, so they are supplementary. Okay, and then measure of angle R plus the measure of angle X should equal 180. That's what supplementary means. They add up to 180. So we can use that information to find the measure of angle R, to find the measure of angle S. Okay, so let's see. S is 86, so we don't know R. So plus 86 equals 180. So we're plugging into this, the two things we know. And then we can subtract 86 from both sides, so the measure of angle R is going to be 94. And then that means the measure of angle R is 94 here. All right, so remember, in a in a parallelogram, consecutive angles should always be supplementary. Okay, problem number 2, using properties of parallelograms in a proof. So use the diagram at the right. So we have parallelogram ABCD. So ABCD is a parallelogram. That means that opposite angles are going to be congruent. And I'm going to go ahead and mark these. There's a lot of other things it means, but we're trying to prove angles, so I'm kind of guessing it's going to work with angles. Okay. Next, we have two sides are the same length. So this AK is the same length as MK. All right. So circle the classification of triangle AKM. So AKM has two congruent sides at least, so it's isosceles. It could have three, we're not sure about the third one. All right, then complete the proof. The reasons are given for you. So we have our reasons on the right, and we have half of our statements on the left. So our first statement should say AK is congruent to MK, and that's just our given. Okay, and then we have angle DAB is congruent to some other angle, and our reasoning here is the angles opposite congruent sides of a triangle are congruent. So if you look at KM, A has a 1 mark in the corner here, and if you look at AK, then M should have a 1 mark in the corner also. So I could pick up this, put a little 1 mark here. So that's going to be angle CMD. All right. And then we have BCD is congruent to some other angle because opposite angles of a parallelogram are congruent. So BCD has a 1 mark on it. It's in the parallelogram. And opposite of that is going to be angle BAD or DAB. Okay. Because opposite angles of a parallelogram are the same, so they both have 1 marks. And now we can see what we need, which is BCD is congruent to CMD. And if you look up here, you can see 1 marks on both of those. So BCD is here, and CMD is there. So those are going to be congruent to each other. And the reason for this is the transitive property of congruence. And you can see from the statements above, we have DAB in both. So we can go from CMD directly to BCD, okay, because we can just cut out the DAB from in between, which is what the transitive property says to do. All right, on the top of page 3, we have problem number 3. We're going to use algebra to find some links of the diagonals in our parallelogram. Okay, so find the value of x and y in parallelogram PQRS at the right. What are P, R, and SQ's length? Okay, so circle the reason PT and TR are congruent and ST and TQ are congruent. And that's because, let's see, diagonals of a parallelogram bisect each other. So cross out the equation that is not true. So only one of these is not supposed to be true. So let's take a look at them closely. First off, if we go diagonal SQ, then I know x plus 1 should equal y. So y is equal to x plus 1. That one works. Okay. And then we go the other way. I know that SQ is supposed to cut PR in half. So 3y minus 7 should equal 2x. So this one works. And then one of these other ones is wrong and one of them is correct. So let's take a look at it for a second. So this one here says 3y minus 7 equals x plus 1. That's a diagonal from one equals half of the diagonal from the other. So this is bad. We can go ahead and cross them out. But why is the first one good? Okay, so if you take a look at the two that we've already circled, and you can see in this one here, we have y solved for, and the value of y is x plus 1. And if you look at this equation, which is also good, all they did was replace the y in that equation with x plus 1. So it says the same thing, 3 times x plus 1 in place of the y, minus 7 equals 2x. Just like 3 times y minus 7 equals 2x. So all they did was put x plus 1 in this spot. All right, so it's a system of equations is what they're doing. So if you had this two equations, you could do the substitution property and then get an equation that has only x in it. All right, so now we're going to find the value of x using this equation. So I'm going to do the distributive property and then combine my like terms. And then I'll move the x over, so we'll have negative 4 equals negative x, and x is positive 4. All right, and then we have to find the value of y. So remember, in the substitution method for system of equation solving, once we've got one, we can just plug back into the other. So y equals 4 plus 1. I'm plugging into this one here, putting x in as 4, and that means y's value should be 5. All right, so let's find the length of PT. PT is equal to 3 times, let's see, so 3y minus 7. So I'm going to replace y with 5. So 3 times 5 minus 7, which is 15 times minus 7, and PT's length should be 8. Okay. Find the length of PR. PR should equal 2 lengths of PT. So since PT was 8, I can put an 8 here, so PR should be 16. Remember that PT is exactly equal to TR, okay, because that SQ bisected that segment for PR. Now we need to find the length of ST. ST's formula was x plus 1, so we replace x with 4, and 4 plus 1 will give us 5 here. And then the length of SQ is going to be 2 of those, so 2 times 5 for 10. All right. Explain why you do not need to find TR and TQ after finding PT and ST. So once we found PT and ST, remember we were doubling them to put them in here. Okay, so we would double it to get the whole length, and that's because they're the same. Okay, the diagonals bisect. So let's see. PT should be congruent to TR, and ST should be congruent to SQ, or TQ. So I only need to find one of them, okay? All right, theorem 6-7, the new one hiding on the bottom of our page here. This one says, if 3 or more parallel lines are cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Okay, so here's my 3 parallel lines in blue, and then we have a transversal that cuts across it, and it made congruent segments in there. So little pieces were cut off, were all congruent. And this says if that happens, then any other transversal that cuts across it should also make little congruent segments. Different lengths ones, but congruent segments. So in this case, A, B, C, D, and E, F are parallel. AC is the same as CE, so BD and DF should be the same also. And then we've already marked our diagram in exercise 28, so we put 2 marks here and 2 marks here to show that those sides were congruent. Okay, on our last page we have problem 4 here, using parallel lines and transversals, so what we just learned. In the figure at the right, all 4 lines, A, E, B, F, C, G, and D, H are parallel, and you can see the little red marks on them in the middle here to show parallel. Okay. And it says EF is congruent to FG, which is congruent to GH, and it's just congruent to 6. All of them are 6 here. Okay. And that AD is 15. So from here to here is 15. And then we are supposed to find what is the length of CD. Now I know you could probably do this really fast because you know that if this transversal made congruent segments, then this one should also. And each one of those segments should be 1/3 as big as 15. But let's walk through the steps here. So you know that parallel lines cut off congruent segments on transversal EH. Okay. By theorem 6-7, the parallel lines should also cut off congruent segments on every other transversal, including transversal AD. Okay. AB or AD, the little segment, is equal to all the big segment is equal to all 3 little segments added together. So AB plus BC plus CD. And that's by the segment addition postulate. 33 here. AB should be equal to BC, and that should also be equal to CD. Okay, so AD should be equal to 3 CDs, 3 of them together. So if you knew one of the little ones, it's just 3 of the same. Therefore, CD is going to be equal to 1/3 of the length of AD. You know AD is 15, so CD should be equal to 1/3 of 15, which is 5. It's a long way to get to what we could do really fast in our head. So remember, if all of these are 6, and then these 3 here all have to be equal. So since they're all going to be equal to each other, and the whole thing is 15, then that's going to put 3 5s here. All right, as always, pause the video for a second, try the lesson check yourself, and then when you're done, come back and check it over. All right, welcome back. So we have an error analysis problem here. So your classmate says that QV is 10 in this picture. Explain why the statement may not be correct. So it could be correct, but it's not necessarily going to be so. So place a check in the box if you are given the information, and place an X in the box for things that you are not given from our diagram. So the 3 lines are cut by 2 transversals. This is true. We have the blue lines, and they're cut by a green transversal here, and they're cut by the black transversal there. Okay. 3 parallel lines are cut by 2 transversals. There are no marks on this line that show parallel, so this is no. Okay. Congruent segments on 1 transversal, this is true. So what needs to be true for QV to equal 10? We need parallel lines. And you might say, well, that doesn't matter. It looks good to me. But here's one that wouldn't look so good. So here are 3 lines that are definitely not parallel. But this transversal could go across it, and these 2 should be the same length. Maybe they're both 5. Then this transversal over here, one of them is going to be shorter than the other. Okay? So let's make that a little more dramatic so we can see it. So over here, these 2 are 5, and this one is definitely longer than that one. Okay? So explain why your classmate's statement may not be correct. If the lines are not parallel, then transversals are not all going to be cut off equally. Okay? All right, so check off the vocabulary words that you understand. So hopefully you have parallelogram. Hopefully you understand what opposite sides of a polygon or parallelogram are. And hopefully you understand what opposite angles are. And then consecutive angles, remember those are the ones that are one right after the other, okay? All right, so how well do you understand parallelograms? And once again, if you're not up here, you should watch the video again. I will see you in class next time to practice this.